Right. So let me present to you Prof Batch, who is a Bavarian hacker and Haskell developer. Um,
I hope you had a good nutritioning phase. We're going to talk about the power to revolutionize Nix packages. And of course, I'm talking about testing, right? Because we're all doing it, it's great, everything's automated, and we don't have any breakage ever on master. Right? Okay, no, probably not. So what do we have right now? We have basically two sets of tests in Nix packages at the moment. The first is in lib tests, and it's testing, like the path says, it's testing the library. We have a lot of library functions, which are basically, because Nix is not a general purpose language, we don't have as much as other languages, but we have quite a few, and we do unit tests for them. Not very many, but I'd say it's okay. And the functions are very simple. You can run them via Nix build, libtest release.nix. And there's a second test set, which probably many of you know, which is the VM tests. These are quite impressive. If you don't know about them, they are basically, you give a module, you give like your system config for one or more machines, and then you say, oh, here's a Perl script which maybe waits for the machine and then connects to the other machine, runs a service and checks for the result, and then says okay or nah. And yeah, and those are pretty fast. You can start one in 2 to 3 seconds, and the tests run for a few seconds, and then you have a complete test. For those of you who don't know the Quake test, which has 2 machines, a client and a server. The server runs Quake in server mode, starts the map, spawns a few bots, waits for the player, the client machine, to join, waits until the client is fragged, and then makes a nice little screenshot, and that is then put into the out path, as far as I know. Maybe I could be wrong, or it could not even exist anymore. Those two sets, they share a problem, or they have a few problems that they share. Lib/tests, okay, it's maybe better than the NixOS VM tests, which are in /nixos/tests, and then there's a whole lot of files, but the real modules are spread throughout the NixOS subtree. So the tests at the moment are pretty far removed from the implementation, which when you are writing a module or fixing a module, you might not even know that there is a test. You might not know how to run the tests, or you might change the module and submit something, someone merges it, and the tests fail, and nobody has any idea where they failed, what failed. Maybe 1 or 2 maintainers know about it. That leads to the second problem. They run separately. So when you change the module, you have to start the test separately. And you have to run them manually. And all of these 3 problems basically lead to desynchronization of the tests and the modules. No tests being written for modules because nobody knows how to write them, or nobody knows that they even exist, and bit rot of the tests, especially in the library functions, where you can change a library function or add a new one and not and tests fail, and yeah. Of course, good CI could fix that problem or mitigate that problem, and good tools could, like the bots that Graham proposed in the last talk, but maybe we can do better. And I thought about the problem a bit, and I came up with 2 maxims. Like what should always be ensured when you write tests or when you write testing systems. And the first one I came up with is the test should be as close as possible to their implementation. If possible, in the same file, maybe right under the implementation, at least in the same directory, very near, where you can always, when you open the folder, you see, oh, test dot. Like when Golang does one thing very right, and that is every file has a test file right beneath it, right in the same folder, and you can't miss the tests. And second thing that is not done very often, it should not be possible to change the implementation without running the tests. And it should not be possible like to even run the implementation without first passing the tests, which might sound a little bit far-fetched, but bear with me, because it actually exists and it works right now. For example, if you are in allpackages.nix and you have the well-known hello world package, GNU hello, the default package, and you want to test if it works without running it manually. Right now the call looks like this. You have a call to call package, and it instantiates the package. I left a little hole in there because it should not even be possible to assign hello without running the tests first. So we should run some tests in between before it gets assigned. And of course, we don't want to recompile hello when some test changes because you added a test or something. So that's pretty much basic stuff. So the hello derivation, which is the right part, it depends on the successful build of, the left part, so the hello assignment depends on the successful build of the hello derivation and some tests, whatever they may be, and however they get run. But the derivation mustn't depend on some tests, because if something depends on something else, you all know it, it will be rebuilt by Nix. We know such a function. Maybe there is a function in Nix which does basically that. It runs the left side and it returns the right side when the left side is evaluated. Yeah, trace is implemented by which function? Yeah, it's a built-in function. It has 3 letters. Sec, right. If you come from Haskell, you know that function. When you're in a functional setting, you sometimes want to have dependent order of evaluation, and then you use sec, which sequential, maybe comes from sequential, I think, and it evaluates. It evaluates the first argument before the second, and then returns the second. So maybe we can just input it into sec, and it will work. Let's try. Calling sec with a new simple derivation, which just writes the text to the file blah, and then returns hello, and we get hello. Okay, that seems fine. And then let's try it with the file foo. We change the left one to foo, and oh, crap. We get the same hello, but the tests have changed, so maybe it should be a different hello, or maybe yeah, we can see that hello clearly hasn't depended on the test. So we are very sad. So could it be that there is a built-in that's evaluating the derivation first and then returning the second one? Maybe, no. So we even settle now. But maybe we can do something about this. And so it happened that one fateful night last year, Aslik and I were sitting in our hackerspace, like two chairs apart, and it was very loud and people were doing stuff, and I had my screen on the presenter and was basically doing a pair programming session with Aslik over the noise of the hackerspace. We were shouting between each other, and I said, maybe we can implement something like that, so then we can improve testing. It would be very much like sec, so we should call it derivation sec. And it has two arguments. The left one is evaluated, the right one is returned. So the left one should be our test, and the right one should be the left one should be our test, and the right one should be our output derivation. So the idea that we had was maybe we can create a new derivation that is exactly like the output derivation, but that runs the tests. So what should we do? We should first collect the outputs that exist of that alt derivation. Then we assign them to the outputs of our new derivation. We get all the attributes which are in der out address and add them to pass-through, so they get passed through to the new derivation, and they will be inside as the derivation attributes of our new derivation. And now we still don't have the test anywhere, so what do you do when you want to depend on something inside a derivation? You just pass it as an argument, and it gets passed to the bash builder or the builder script, and everything's fine with the world. So now we have a new derivation that clearly depends on our test. Of course, now we have all the meta attributes in place, but there's still a file left. So we thought a bit about that, and just tried following. I took our alt outputs and mapped over each output a little bash script. I did some shell escaping. I resolved the link so that it points to a real file or directory, and then we symlinked it into the Nix store, and it worked. Aslik didn't think it would work, but now we had a complete copy of the old derivation, and basically the devsec function now works as intended. We can expand it to a list. A functional programmer would maybe think now we have a little for a single element function, and now we just fold over the single element function on the list, and that creates a lot of symlinks that we don't want. So the pragmatic programmer just turns it around, and the list version is the primitive, and the one element call is now the devsec function. And we are at the moment, now we can implement our with tests function, and which takes an attribute set of tests, which are shell scripts with names, the red one, and the output, in this case hello, puts something into devsec which is a list of tests, and then the original output. Each test will be put like plain text into a script. Out is touched so that the build doesn't fail. If the script didn't fail, the build will not fail. And yeah, basic run command stuff. And we've got a test. To see that this works, Sekai konnichiwa, hello world, hello Welt. We use the new hello program. We changed the derivation a little bit. So we put the original make derivation inside a let, assign it to the name hello. Oh, I reset my timer, okay. And call with tests, with our new tests. So, what could we test for GNU Hello? Do you have any ideas? Maybe. What's the most basic thing you can test for a binary? It runs and does not crash, right? How would you test GNU Hello that it runs? Which is kind of simple. It's just execute it and check the exit status. Or if you're really fancy, you even check, like you grab hello world, and yeah, and that's like a test script. And in a business world, you would call this an integration test for hello world, which is quite fancy. We could go a little bit further and check the version output. And ooh, you can depend on Nix values which you previously defined in your let binding. So we can now test if the hello world really is the hello world that it says it is, or at least the developer didn't forget to change the version string, which already happened with some Python packages. And when you run that, you don't run it, you just say nix build minus a hello. You can see it's building the hello test, which gets KDL. Then it's building the version test, which gets VND, which are just shell scripts that are then put into our new hello and run. As you can see, it first outputs hello world and then the version number. Those are grabbed, so if the grab doesn't work, it will exit 1 and the test will fail, and you get a new hello. Right, yay. This doesn't stop there, because that's just bash script executing, which you can do manually. But you now have the full power of Nix at your disposal to bring revolution to testing. If you look at the old, you can see the duplication. There's been hello twice, and then you grab twice, and so why not just capture it, refactor into a function match standard out, which has an invocation and a regex, and will have a nice error message if the regex doesn't work, and capture the bin hello part, and now the tests look like this. Just two normal Nix functions with a bit of string interpolation. What if we want to grab for goodbye sad world instead? This will happen. Hello test will try to get built. We get our nice error message from our helper function. Output did not match. It was goodbye cruel world. It should have been hello world. No, the other way around. It should have been goodbye cruel world. It was hello world. And the builder for the test fails. And as you can see, the other test doesn't get rebuilt, and hello doesn't get rebuilt as well. Right. So that's basically the idea behind Nix package testing. Package testing, not VM testing. You just need Nix build process. I tried a few things, like what can you do with that? How can you integrate tests inside normal derivations? And the first thing was to eat my own dog food. So we now have the testing functions. Why not test the testing function? For that, I quickly noticed that I needed to actually run Nix inside the Nix build to generate the output of the tests, so I can grab the output of the Nix run. So I thought, well, that's it. I cannot go any further. Then I grabbed a little bit inside Nix packages, and inside lib/tests, they already have something like that to run the Nix invocation, right? So I factored it out into a shell script, and then I started testing the shell script first, because who knows if it is wrong or if it works or doesn't work. So let's test that script. Like run Nix instantiate on a simple derivation, then use that derivation, run Nix build on that output, and look if and see if it outputs what the derivation build script said it should output, and grab for that. And now we have guarantees that the Nix invocation actually works, like that Nix actually does what it should do. So we basically did an integration test for Nix. Sorry, I don't have scripts for that, outputs for that. But yeah, step 5, that's a horrible joke. Nobody here understands, and I'm sorry for the 2 people that do. Yeah, another idea was, well, you have like beats, which is a music tagger, and I could run beats in a test and do version checks. That's actually really nice for Python packages, because maybe a lot of you know that Python, if builds, it doesn't mean it actually runs. Like most Python binaries just stop with an import error in the first line. So we could actually now test every Python binary, for example, for a version string, and automatically get guarantees for the whole Python set. I don't have it in this presentation, but what you can do is use the build Python function, get in the argument, insert the with test function, and do a nice call, and then you can actually test functions for every input they get. And for every input that is different, it will run a different test. For example, a Python package. That could be done. It actually works. No idea if we want that, but this is a nice thing that only happens in Nix because you have a short evaluation phase, and yeah. So if you have that music tagger beats, we can actually go a little bit further and call a different version of beats inside our tests. And since we assign it above, the 3 dots after beats are the implementation of beats, then we have the full package with override capabilities, and we can override that full package inside the tests, like enable a plugin we want to test, which is not enabled by default. That's one way, yeah. Another proposal I have, which goes towards the VM tests. Right now, as I said, the VM tests are very much in a different folder than the actual modules. So why don't we just integrate the tests inside our modules? Keeping the first maxim I defined earlier, keep tests close to implementation. These VM tests are at the moment run by Hydra. There's a list of tests which Hydra runs, and it's basically an attribute set which is nested in arbitrary deep nestings with packages at the leaves. So if we could add arbitrary nested attribute sets to the module system, then we can just add a test attribute. Right. Then inside each module, you can set the test attribute to like your foo test, which is a derivation which runs a VM test. And in Hydra, oh, where's the Hydra part? Yeah, and in Hydra, it basically gets a config set and calls it config set. Don't know why it's missing. And this is like a different testing approach than before. So I left the package tests. Right, you can define the type which takes like address of or list of, and the second attribute like int, bool, whatever. And then you can say, oh, our test is a nested attribute of a nested type of attribute sets of packages, and yeah, that will do what you want, and you will get a nice list of tests for Hydra. So I'm still actively working on this and have been for the last year or so, on and off. And I want to hack on this at the hackathon on Monday and Tuesday. First, the with test interface might get changed a bit, like having shell scripts might not be the best interface for a generic interface. We should implement a few tests for packages which are a bit more complicated than Hello World. Then we should do a pull request with the primitives and the example packages. Yeah, normal stuff. Before I go, I have 2 more things I'm working on. I'm working on a tag union type for the type system. For those of you who miss the sum type way of doing type definitions, you can now do something like that, which is like my hard drive has a power management value, and it goes from 0 to 8 bits, and the 0 is off, and 255 is something, and 200, and the first half is some value, and the second half is some value, and now we can do off or low from the low values and or high from the high values, and you specify that, and yeah, that gets type checked. And I have a little project which does enumerators, small check like enumerators for Nix values, also with the module system to test changes in the module system. Right.
All right, goes fast.
Great idea. For the package tests, where would you put the actual tests? Because, for example, in the Hello World example, in the all packages we have the Hello World attribute.
Yeah.
I guess you won't put it there, right? Because that would, then it would, the all packages would become too big.
In the old, so I had the example earlier, right, over here. I started with in the first example, I had something like
Yeah, the call package Hello World, and then
tests equals empty space call package, and we don't want to put the tests here because that's why in the actual example here, why I put this inside hello default.
oh, hello. Okay, I missed that. Yeah.
So we define the package in a lab binding and then use that for the test. So we have this in the same file, which is as close as you can get.
So how does this work with depending on tested packages? Since the output path changes each time, wouldn't that result? So if you add a test to some library, wouldn't all the packages depending on that library need to get rebuilt, even though the library itself is still the same?
If you test the library and add a test, yeah, that would probably happen.
So but that's not something you.
That's always a problem if you have the tree, and if you change something in the tree, which is transitively depending, where executables are depending.
Yeah.
You will. So you probably have to. Still, you have to create a leaf, which then tests the library. Or you can test the library and rebuild once, and then test for everything that goes through that library. Yeah.
Yeah, interesting talk, thank you. One thing that I would like to mention is that even though I find it fascinating, I also find it somewhat scary, to be honest, because integration tests in general tend to be a maintenance nightmare. And so anyone who has ever done or maintained integration tests for a non-trivial project maybe experienced that at some point. So in the end, if you have some non-trivial program, and well, Hello obviously is a trivial one, and you have someone going overboard with tests, like that funny little Quake example, and then at some point in your super elaborate tests, which is like a couple of hundred of lines of bash code or whatever, something somehow goes wrong because maybe some sort of semantics of the tool changed, and the package that you're testing might still be entirely okay, but now you have to, you have to not only maintain your program but also your elaborate tests. And I find that prospect actually scary, because in the end, you update something, maybe you want to do a drive-by contribution, and you upload the version, and then something somewhere changes, and you have no idea why and what. And so I find that scary.
So that I think that's mostly a problem of testing the wrong things. The only thing you want to test is things you have you absolutely want to be true. Not things you think that might be true, or things that you think that might be true that are true at the moment because the test passes, which is a bad thing to do. But guarantees you want your packages to give, like, does not crash with an import error for every Python executable, thank you very much. Or, yeah. And the second part was, I lost it. Mm. Ah, right. That's probably the main the main problem with implementing that is making sure the error messages fit the tests, that you don't get any empty lines when something crashes. And that's also a problem of getting good testing library support, where you have a testing library which has basic building blocks which then give good error messages.
Oh, I just wanted to respond to that also. Like it sounded like, I almost feel like characterizing it as integration tests is sort of blowing it out of proportion. I mean, these packages have tests of their own. So what we're actually testing is like a sanity smoke test type thing of like, does this thing crash at startup? Like those are his examples. Like if these things become complex, I think we're doing it wrong.
The integration thing was mainly a joke.
Yeah.
And to trigger some people, and I succeeded. Yeah, if it's a good program, it will always behave the same for the same inputs.
Why don't we just write a test derivation besides package derivation and let Nox review build the tests? This way we avoid rebuilding packages that depend on our package when the tests change.
Do we mean libraries or?
Well, you described how to wrap a package with a dummy package with some links it outputs. What if we don't wrap the package with a test package, but add the tests package, for example, in all packages?
Ah, right. You mean there is already a test phase inside our make derivation standard env right now. The problem with that is these are good for tests that come from upstream. Like if you have a library which does tests, unit tests, and they get run, and if they fail, this is an upstream problem. But if we add integration tests, we don't want to add them to the check phase, because then after our build, the build will fail and we have to restart the whole build.
Well, I don't mean the check phase. I mean that what if we add another derivation, another package in, for example, in the all packages? And
you mean like another leaf, like another executable, which then gets collected and tested in?
No. I want to exploit the fact that Nox review rebuild. I'm not sure. I wanted to rely on a Nox review to run the tests. This way we don't have to force Nix to run the tests every time we build a package.
That's maybe that wasn't clear from the example. When I run this, and when I run it the second time, it will always be a single operation, because I don't have to rebuild the tests.
Yes.
As with other derivations.
I think what he wants to say is, why don't we like just add a like a pass-through attribute which doesn't change the derivation,
Yeah.
which isn't picked up actually while building, but only like with a extra tool that specifically runs the
That
tests.
could be done, yes.
That would like fix the rebuild case.
Yeah, it violates the thing I wanted to guarantee. So it's as always there's two like whatever your use case is, and it's if it's higher up in the tree, then you have to be very careful what you change. And if you add a space to a standard and bash script, you will trigger mass rebuilds. You have to be very careful with testing as well. So the higher up in the tree it is, the more conservative the tests have to be. And if it's like a Python script nobody cares about, then just bash it with tests. Bash it with tests. Okay? Yeah.
Intentional subvert fail.
Or intentional stores. Right.
All right, thank you.
And maybe if Elko doesn't like this thing, then we could maybe add it as a built-in derf sec. Yeah. Right.
Thank you.
Our next speaker is Nicola, who you probably know from the module system. The one thing I definitely know about Nicola is if something annoys him strong enough, he'll do something like implement the module system. I have more notes. He works day to day at Mozilla, recently working on a new project called HolyJIT, which is a just-in-time compiler for JavaScript written in Rust. Go ahead. Thank you.
So one thing I was looking for a logo for this for a first slide for this presentation, and I was trying something with overlays, and I figured out that we already had overlays. We just need a bit of transparency to see them. And adding transparency in the logo, you can see that we already have overlays, and we also had a fixed point. We had to, the logos had a way to fix the depth of printing it. And if you recall some old T-shirts, it's not always easy to understand fixed point, especially if you are a printer. So the goal of this presentation is to make sure you understand overlays and make sure you understand them correctly. I gave to the Nix community a gift for Christmas. I give you overlays, and almost a year after I come back to and went to the web and looked for things where people used overlays and realized that, oh crap, people have used it, but there are things that are in the documentation which might be not well explained, and I hope this presentation will clarify that. So I will go and describe what they are, how they work, and what you can do with them. So NixOS is awesome. We have the module system, which gives us the ability to be declarative, and this module system also gives us the ability to compose different modules from all over the place and make that into one set. Except that, okay, that's nice, but not everything is awesome. Sorry for the Lego movie. But Nix packages is like, you have these functions and they return something. It's not that much of declarative. And it was not composable before overlays. And we will see how overlays make that composable. So before going into overlays, let's look at how we used to extend Nix packages before that. Before that, we had these three functions. And these three functions were like, okay, there is package overrides that everybody, or almost everybody, use in config.nix. And it's nice, you can extend things, you can change the sources, okay, great. But you cannot share that easily because you have some custom stuff, and it's like there is this one file, and if you want to share that, you have to share a portion of it. And we're back to the problems that I had before making the NixOS modules, which were, okay, how do we avoid getting into forums when we want to have a solution? And how can I just share a file and just pull that down? Then we have this other function, which I'm glad I removed it, which is override packages. And if you don't know about it, don't go dig. Don't dig further. It's like awful and it's no longer there. It's not even try to use it, it won't work. Then there is this other style, which is like, okay, I'm from an external file in another project and I want to import Nix packages and extends these versions that I imported and adds these few packages inside it. That works well until the point where you want to add multiple, and then you realize, okay, then I want to import something else that needs packages which already extends it, and it's becoming hell. So all of these methods are replaced by overlays, and the second one no longer exists. Great. Soon, maybe, I hope to break all of you if you are still using that. So composable, we can compose overlays in a way where we have the same syntax for all of them. We have a simple syntax which is made to copy and paste, and that's basically all. And then you can do all the things that you could do with the overlays before, which is like you can add packages, you can replace some of them by tuning them, you can change the recipe, and you can remove some of them, which, for example, say, oh, xlibs equal null. Yep, no more xlibs, which will break tons of stuff, such as Emacs, I guess. And the way overlay works is that you have one directory or an option in NixOS, or a single file, which got added recently. And this one directory lets you add files at a coarse-grained granularity. And you add files into this directory, and this will be overlays, which will be used one after the other, and will be combined into Nix packages. So I will go through multiple examples. And after a while, I will ask you to solve some of them. So I will go with the easy one. So this is the simplest overlays that you can make. It takes two arguments. One is self, the other is super. And you give it an empty set, and you extended Nix packages with nothing. Great. So overlays are not just some things that are made up. It's actually the internal of Nix packages. Nix packages is using the overlay system, except that it's doing a mess, which is currently elided in this slide. And it's using the overlay system to basically stage the different levels of Nix packages that we currently have. So this basically, the things that I did was like, I was trying to do the grafting work again. Yeah, if you recall the presentation from 2 years ago. And I realized that, there is this function, override packages, which gives me tons of trouble. And I can replace it and just add overlays at the end. And that's basically all it is. Overlays are just adding something to the internal of Nix packages, and you get to extend all of Nix packages. And I can remove one of the side features that was there and was awful in terms of performances, and hey, no longer here. So no, we have overlays, yes. So a simple example that I found on the internet, it's quite a full, it's resourceful, the internet. You find tons of things, and sometimes you find good examples. And this one is just adding a command line argument to Google Chrome, which is saying, hey, use this proxy to redirect all my network connections through this proxy, which is really nice, especially if you can set it on the command line and get all the nice feature and protections that you get with a proxy. So, okay, that's a good way to get an overlay, and you get to recompile Chrome once more. So, while we are discussing about recompilation, some other people wanted to get Nix, but in a different directory. And basically, this is interesting if you are stuck in your home and you have no root access for adding the Nix directory at the top level. So this is a simplified example, but this has the same ideas, which is that you want to configure Nix to have its Nix store at a different directory. And that's an interesting one as well. So then you have other example where you just have ordinary packages, as we do in Nix packages, and that's just one of the tools that we use within Mozilla for discussing. So we saw this self and super, and it's not clear when you see them. So self is basically, in Nix packages, you have a fixed point. You have all these stages, and you have a fixed point which basically takes the output and give it back at the input of all of them. And super is, you have all these stages, and it's the previous one. You take the next stage, it's the previous one, and so on. So that's basically all it is. But that doesn't tell you how to use them. Self is made to basically find all the dependencies. So if you have a package, and your package depends on sed, on Bison, on Firefox, then you will use self. You will say self.sed, self.bison, self.firefox. And that's all. If you want to use self for anything else, that's wrong. That's the only bullet point here. That's the bullet. Super is basically all the rest. Is if you have functions called packages or library functions or write text or run command, if you have functions, it comes from super. If you want to override the recipe, it comes from super. It comes from super for the following reason. Let's say I have sed, I want to override something in sed, and I want to, after overriding something in sed, I want to define it as sed. You get an infinite loop because you say, I want the recipe of the thing that I just defined. And that's why you have to look for recipes for making packages in the previous ones until you find one. And that's why also overlays are ordered as opposed to NixOS modules. So, okay, we saw self and super. Now, I will ask you to raise your hand as soon as you find the issues in these examples. So if you find one issue, raise your hand that way. If you find two issues, raise your hand that way. And if you are watching this talk remotely, then you have the end key to see the answers. Okay, I see a few ends. So the first issue is like write text. Write text is basically it's a function. It generates a derivation, but it's a function. As a function, it comes from super, not self. And the other one is a bit subtle to see. It's the fake closure. The fake closure is coming from above because of the rec keyword. And it's not nice to make an overlay which is using the rec keyword, because if you're using the rec keyword, basically that means that you're looping within your overlay and not from the from the Nix package's fixed point, which means that an overlay which comes after has no opportunity to change that. So the fake closure loops inside instead of looping around, and if you want to give more opportunities to your users, you should use self instead of rec. So let's look at another. And this other one has one issue and same thing, raise your hand as soon as you see it. Hmm? It's just above. The question was, where does Python come from? So you're almost on the thing. So this is not an overlay. And the problem with this one is that there is this Python argument, and this Python argument is it has to come, and if you want to make an overlay, it has to come from self or super. In this case, you're using the override derivation, so it should probably come from super. And this Python is like, if you want to make something which depends on a specific name or a specific attribute within the overlay, then you should probably use it as a name of the attribute and make it that way instead of using Python as a package. Okay, another example. Yeah. Where is he, by the way? So if you are watching remotely, Garbas, I hope that you will fix your code. So this code has multiple issues. One of the issues is like, why do we import Nix packages twice? You first import it as the argument, and then you use the path which is inside it to import it again, which is terrible for people who are who want to do, for example, cross compilations, because then you got a different system, and if you were to import a package set which was configured for a different system, then you import it again, and you lost all this system customization with this one. The other thing is that you have this overlay which is defined within this file, and within this file you have like inherit packages, which is the one which is that argument, and that's completely wrong. You're basically, you have 3 versions of packages. That's just, and if you're cross-compiling, that's even worse. You might even get the wrong one. So what you want here is basically first split it into 2 files. And then you want to remove the package and probably use self or super. So that's how it should look like. You have one file which is, okay, get the path of Nix packages and only import Nix packages once, if you want to do that. Then you have this overlay, which is probably a default.nix or whatever. And this overlay doesn't depend on packages, it depends on self or super, and gives that to the requirements.nix. And that's all. Split the files, it will be nicer and smaller in terms of code. So I have again an example, and same thing, raise your hand if you see the issues. So here's the issue is basically you have packages that you depend on and you want the derivation out of them. So call package is a function that you get from super, okay? But the things that you give as argument, which are dependencies, such as the VT package or Lua5, are derivation, and you want to get them from self, such as somebody else can override them. So let's look at how overlays work and how we compose them. The logic of the composition is this update operators that is in Nix. So we have two sets, and we will make this example a bit more complex. These two sets, we use the update operator, and that's fine, it returns a set. Then we go one step further, we add super. Super is the previous one. So we give as argument of bar a super argument. And the super argument will be the left-hand side of the update operator, which is the foo, even a super argument, which is an empty set. So in this case, we have that. There is a missing part here, but that's just for simplification. It does not give anything. Then we generalize the update operator and give that the name extend, which is not exactly the same as the one which is in the library, but probably we shall rewrite the one in the library. So the way it works is exactly the same thing. It's like you have the left-hand side and you have the right-hand side, and you call the right-hand side with the left-hand side as argument, and then you have the update operator. And with that, you can use them and compose them already with starting, okay, I have foo, which takes the empty set, and the result of that, I give it to bar, and so on and so on. So we can make that for a list, and we can fold that and saying, okay, use this extend function, you have the empty set and so on, and you iterate over the list, and that's basically how Nix packages work. And you can go even further because you want to have a fixed point, and your fixed point is basically saying, okay, now I have this self argument to all of them, so you have all your overlays in the list, and you have the fixed point, which is basically giving the self argument to all of them. So this is what the fixed function is doing, and the map function is doing here. The map function is here to forward the self argument provided by fix to all of them. So here we can almost take the previous example and make that into, hey, I have this overlay which takes self and super, and compose all other overlay which are in the same directory, such as foo.overlay.nix and bar.overlay.nix. And that's really great, and we have a similar example in Nix packages Mozilla. So let's see if you can spot the issue here. Know that you know how it works. It's supposed to add packages and be a friendly overlay. So I see a few ends, and the issue here is that you have lib and you have latest, and these two are attributes, and the way the update operator works is basically it will erase the previous one with the new value. So basically what you're doing here is erasing all the library functions by this Firefox version one. And that's not friendly. That's you're erasing all the work for all others. So you want to make sure that whatever you do, you at least extend what was already in this attribute before. So it's not yet settled, but we are trying to go into making a convention, which is like if you are making an overlay which has reproducible packages, then that's fine. You go to the top level. If you have utility functions such as, oh, I want to parse some things, then you go into lib. If you have packages which are updated automatically without doing anything in terms of changing the sources, then please don't go at the reproducible packages, because that will be a hell for anybody who wants to make a reproducible environment. So go into latest and add your stuff into that. And if you want to make a shell environment which is not dedicated for building anything, then probably go into dev-env or some similar names. So these are conventions. It's not enforced yet, but that's just play nicely and think of everybody having the same conventions. On the same side, it might be nice if we had a similar naming for Googling or searching this set of packages. So currently at Mozilla, we have needs packages Mozilla, which is Firefox, Rust, and some other tools. And if you are making an overlay for some specific package, then you can probably name it after the name of the program and say -overlay.nix. This way, somebody can say, oh, I want to pick only this one and symlink it to the .config packages.overlay directory. And if you are making a repository which is containing only overlays, then provide a default .nix which aggregates all of them if you have multiple ones. So what can we do with overlays? Overlays are quite powerful in terms of, yeah, we can compose and that's nice. And we can do something such as fetch from the network because we have a new built-in for fetch URL. And as soon as you fetch something, you have another problem, which is parsing it. Then you have to generate derivations. So I will go for the few examples, sorry if it's a tiny font. So fetching from the network is simple. You have the fetch URL, it will take a URL and put that into some file somewhere, and then you can go and parse, okay, I have a JSON file. So in case of Firefox, we have a JSON file which gives us the version number of the various branches, such as the nightly is 58, the beta is 57, and the stable is 56. This version gives us basically, we can derive from this version the location of some checksum file. And this checksum file has a specific layout, which is the hash, then some other information, and the name of the binary. So you can use the built-in match function to basically use the regex and filter the parts that you are interested in and get, for example, I know what is the file names that I'm looking for, give me the hash, and then I can generate a derivation for that. So the way the Firefox.overlay works is basically looking at this file, extracting the hash and the binary name, and then generating a derivation which is like, okay, no, your sources are fetch URL with a SHA and a name, and that's all. So I got a remark from the side that you cannot parse context-free languages from regexes. Yes. But they are clever guys. So if you look at the Rust overlay, it's a bit more complex. So there is first the fetch part, which is basically reverse engineering Rust up, which is a common tool in the Rust community, which is like, okay, I want to update the Rusty compiler to this version for the next, for everything which comes next. So this basically is a reverse engineer of Rust up, which is, okay, how do you get the address of the 2ML file, which is depending on the channel at which you are, or the date, and the location of where the files are distributed. And that's basically how the fetching of the metadata is made. And it goes through HTTPS, such as at least we know and trust the static rustlang.org. And that's how we fetch. Now, let's look at what we get. So we get some nice language which is harder to parse with regexes. And this language is a 2ML. It's basically a HINI file which has the same syntax as we have in Nix for having the dot notation for attributes which are under multiple layers. And then it gives us like, okay, you have this package which has this hash and a bunch of stuff. And it even has list if you have two braces on both sides. So, okay, that's a nice format to look at. And we can make a parser for that. So, for making a parser, it might be nice to split the phases into two and first make a tokenizer. So, how do you go and parse this 2ML file? You basically make one big regex, which basically expresses the list of tokens that you expect. And you also express the layout, and that's give you not yet a tokenizer, but the basis for it. Then you have a tokenizer function, which is using a new feature of Nix 1.12. You can look at the old version, which is in nixpackages.mozilla for Nix 1.11. It's a bit more hacky and not as stable as this one, but it's more challenging to understand as well. So this one is working by using the split function. The split function is basically taking a string, huge string, and looking at the token and split your string with, okay, I have something which is not a token, I have something which is a token, I have something which is not, and alternating between the two. Then as we go and alternate between token and non-tokens, then we have to filter out all the things that we are not interested in. And if there is something which is not layout as part of the non-token part, then we want to throw saying something, okay, I don't understand your 2ML file. And that's basically what the filter layout function is doing. So now we tokenized as we isolated the things which are tokens and the things which are not token, except that we still have text. But that's good enough for us. So now let's make a parser. So a parser is kind of simple. You basically got some text, and you're in a state. So instead of making your parser where you go and do a recursive descent through the information that you got, we have to mutate the state, mutate. The reason why we cannot do a recursive descent into a parser is because Nix has some recursion limits, which are not directly tied, made into Nix, but made into the binary which is interpreting Nix. And we cannot use a recursive descent because of that, and because it will be way too huge as soon as you go deeper into this level. So the trick here is basically, if you think of it as an LR parser where you have state, and each time you move from one node to another, you change your state. Then you have to remember what is the state. So we want to have one operation which is applied every time in a sequence and which does not consume stack. There is a built-in which is full del and with the apostrophe. This is a built-in which is kind of special compared to the full del implementation in the library, except that it defaults to it now. This basically avoids consuming stack. It will call every time the function, but will not increase the stack space for every element in the list. So we have an initial state. This state is like, okay, we are in state 0, and we have some context. When we iterate through the tokens, we basically, okay, we're in state 0, then do the match, for example, the name, and stores the name into the state. When we are and we increase the state counter, so we are probably in state 1, and in state 1, we expect the token to be always equal. So that's what we have in syscode, and so we say, okay, no, we it's the token equal, so let's go to state 2, and in state 2, we match, for example, a value, which is a string or a boolean or whatever, and we have this token to value function, which will give us the value as the Nix value interpreted from the 2ML file, and we will set it to the name. So that's really simple, honestly, and it's just going through state and saying, when I hit this token and I'm in this state, then I go to this other state. So we made a parser, and now we got to deal with the fact that the system is not represented the same way as the systems that we have in the manifest file. And so we implement a switch, which is like, if you give me the system in Nix, I can give you the system for the tarball that you're looking for. And the switch in Nix is just an attribute set, and at the end you say, oh, I want this attribute. And if it does not exist, then you complain about it. So we went through the overlay, we saw that we can make it compose files, insert it into the fixed points. That's really nice. It's not yet declarative. And we can fix that. But that will be the subject for another talk probably, because there is an RFC which is in the pipe, which is simple override strategies, which give us the ability to have a single syntax for all the override functions. Like override derivation, override, and whatever you can think of, it's basically should be expressed with a single syntax with this model. So that's basically the end of my talk, and if you have any questions, please raise and I will try to answer them.
Thank you. I have a question about when to use the self and the super argument in your overlay. Basically, you're saying when you want to use a library function, you should use super, right?
Yes.
What if you you have an overlay, you want to extend lib with your own library functions, and in the same overlay you want to use these library functions inside your packages? Shouldn't you do that? Should you then have two overlays? Or should you, because you can't use self in your...
When you have a library function, you are supposed to use super. When you are defining the functions, you have already access to it. So you could make it two. I won't recommend it because you can just use the ones that you have. So
right.
Just use the ones that you have, it won't matter that much.
Oh yeah, if you have them in a lat binding, then you call them directly. Right.
But exposing them is nicer because that means that others can work on top of the work that you did.
One quick follow-up question. In NixOS, you also have this lib argument that your module gets. I found that when you override the lib from Nix packages, those overrides are not accessible in the lib argument of the NixOS module. So I always use packages.lib in my modules, but I've read somewhere that that's not the right thing to do. You shouldn't call, but how do you, basically how do I make it so that my own functions are accessible from lib, from a NixOS module?
So packages.lib shall not be used, indeed.
Yes.
The problem that you have is that the lib that is given as argument is basically used for the evaluation of modules. So unless you're modifying the module system yourself, then you should be fine to use packages.lib. And the separation of the two was basically made for that, to split the module system part from all others. And
okay.
The problem is that people tend to use packages.lib to get make options and make default and others.
Yeah.
And this is where we had to say, no, you shall not use packages.lib. So if you have custom functions like the Firefox versions that I saw before, yes.
That's safe. That's safe to use.
It's totally
okay.
safe. That's as long as you make sure that you don't use module system functions from another libraries than the ones that you have for evaluating the module system.
Very clear. Okay. Yeah, we don't do that already, so that's fine. Great.
Cool. Following up on that, I do self.callPackage all the time, and it works great.
So I will be happy to break your code soon.
Challenge accepted.
So when you use self, it's one iteration slower because you have to go through the fixed point. It's not a big deal in terms of performance. It's a big deal in terms of concepts because my goal is aiming for grafting and for the simple override strategies. And the problems that you got by not using this super for the call package is basically that you are adding an external op going through the fixed point. So call package, if you use self for call package, you will say, okay, I'm here, I'm going through the fixed point to find call package, and then call package itself is using the fixed point to go to the dependencies that you have, or the dependencies that you have. And you're going twice through the fixed point. And this is a problem for implementing grafting later, because the way grafting works is by peeling off the fixed point and making sure we can have another version of Nix packages to make the deltas and make sure that we can do the grafting.
I just wanted to make a quick warning. The regex syntax in Nix 112 has changed, and so be very careful. And also in Nix 111, there were two regex syntaxes, depending on which platform you're on.
Yes, I had this problem too.
Actually, I think fetch.url also requires a SHA-256 now.
The built-in doesn't. Mic throwing is a dangerous process.
So, do you think that, I've sometimes had issues with overriding packages because, so using override actors, because they, rather than having some sort of fixed point, they just use rec. And I'd like to be able to override stuff like the version, which is then referred to by the expression itself. Do you think an overlays-like system would be helpful for that as well, or reasonable, or possible?
You mean within each of the package?
Yes.
So the simple override strategy should provide the answer to that, because it's basically giving you a declarative way of writing packages, and you no longer have a function, which is like stdm to make derivation. So you get just an attribute set and no rec, and you basically can get all the information out of it. It might be a bit complex in terms of concepts, but the syntax is still to be discussed, and we should aim for making it simple to read. And it should solve the problem of having the version, because the version will just be one field in a set that you can override without going through override derivation.
Thank you.
It's closer.
One first simple question is, why is it called then self and super? You could call them packages and functions, for example. That would be much more simple.
So there is one thing which is called legacy. And yes, we should probably rename them at one point.
But anyway, even it's in my file, so I can name them like that.
Yes.
And does it make sense?
It totally makes sense.
And if it's so easy to fuck things up and use the wrong one, isn't it possible to enforce that we are using the wrong one, the right one? Why are packages available in both? If you should not use packages from super, then just disable the packages in super.
You cannot disable the packages because they are the result of the make derivation function.
But can you?
But you can disable the functions from going through the fixed point by putting null on them. That will be one solution to avoid using function from self.
Yeah, that would really help to have just an error going up saying, okay, not possible, do not use this one, use the other one.
So it is possible for functions. It's harder for packages, unless we are going to the stage where you can only get derivations if you go through the fixed point, which is like we will have to have a post process at the end of the overlays and others stages, which will basically convert every recipe into its derivation counterpart.
Is that something that we could implement in like 2 days in a hackathon, for example? Just
Maybe it will break some code.
All right, last question.
So you go through a fixed point with self, and what is it you do with super? Will it just descend until the empty attribute set is reached and check for all attributes inside, like the innermost loop?
Yes.
And do you have have you read into recursion schemes? Maybe because this reminds me of recursion schemes and maybe there's a term already for that, because you have different kinds of.
So we
of,
don't have a recursion problem when going through super, because super will just go back until you find basically the attribute which is the empty. When you find the empty set which is at the root, or it does not go back, but you make attributes which are becoming larger, and you poke into the last one. You have recursion issues when you go through self, because self is basically you can define yourself.
Yeah, you're going through your own definition
Yes.
round and round.